Hello again everyone. In this video tutorial we will be integrating this given example. Before we get started, we can write this integral as this. As you can see, I can write sine square of x dx. There's no difference whatsoever between these two. The next thing what we're going to do is we will be using the trigonometric identities to take care of this integral. So this is the trigonometric identity that we will be using. Cosine of 2x equal to 1 minus 2 sine square of x. You might be wondering, how did we get this identity? So I will explain it to you and I will prove it for you a little bit later. So before we do that one, let's take care of this integral first. So from this equation, isn't it, I can write this thing as, I want you to move this negative 2 sine square of x on the other side, and I want you to move this cosine of 2x on the right hand side. So this could be written as, if you move negative 2 sine square on the other side, becomes 2 sine square of x equals to 1 minus, when you move cosine on the other side, cosine 2 of x to become negative cosine of 2x. Now what I want you to do is, I want you to divide across the board by 2. I want you to divide by 2, divided by 2, and divided by 2. So that means we're going to get sine square of x equals to 1 over 2 minus cosine of 2x divided by 2. So this is, right now what I'm gonna do is, now I'm going to replace sine square of x by this quantity over here. So I can write this thing as, you can see that thing, I can write 1 over 2 minus cosine of 2x divided by 2 dx, isn't it? Now you can use one of the definition. You can expand it. You can write 1 over 2 d of x minus cosine of 2x divided by 2 times dx. So far so good, piece of cake, isn't it? So I want you to bring this constant 1 over 2 outside. I can write 1 over 2 dx minus, once again, 1 over 2 cosine of 2x dx. Now look at over here. This is how much? This part is simply x. So I can write 1 over 2 outside, and this derivative is, integral is simply x minus 1 over 2. Now we're going to take care of this integral, the one right up here. So this one is going to be simply, let me show you an easy way of doing this thing. Always remember cosine of 2x dx. So our argument is 2 of x. Just keep in your mind this thing. We know one thing, that the integral of cosine is simply sine of whatever that argument 2 of x. Then what I want you to do is, I want you to take the derivative of this argument 2 of x. 2 of x, the derivative of 2 of x is 2, isn't it? Whatever that is, you divide by that number, that derivative 2. So that is going to be our answer. So I'm going to write it down over here. This way, by the way, you don't have to use a substitution method. So this is super easy way of doing these kind of problems. So I want you to write it down, sine of 2x divided by 2, and then at the end you put down c, where c is an arbitrary constant. So over here, simply what we got is x over 2, we can write x over 2 minus 1 over 4 times sine of 2x plus c, and that is our answer. And finally, as I promised, now I'm going to explain it to you. How did we get cosine of 2x equal to 1 minus 2 sine square of x? So here is the explanation. Recall one thing, okay, that the sum of the angles cosine of alpha plus beta, two angles, is always equal to cosine of alpha cosine of beta minus sine of alpha sine of beta. I'm sure you are aware of this fact. And now what I did is, right now we can use this fact for this one. Cosine of 2x could be written as cosine of x plus x, and then you use this fact. So this turns out to be a cosine of x times cosine of x minus sine x times sine of x. So cosine and cosine give you cosine squared minus sine squared. Now here, one more thing, another identity. Remember that sine squared plus cosine squared is always equal to 1. That means cosine squared is going to be 1 minus sine squared x. So I replace this cosine square by 1 minus sine square of x, and here minus sine square x is already there. Once you simplify, you got the same fact over here. Did you see that thing? So thanks for watching, and please subscribe to my channel for more exciting videos.